Assalamualaikum and good day everyone. We are still under chapter 7, that is permutations and combinations. For today's lesson, we are going to learn conditional permutations. Learning outcomes for today is to determine the permutation of a set of objects with conditions. Example 21. Find the number of arrangements of 4 digits taken from the set 1, 2, 3, and 4. In how many ways can these numbers be arranged so that A. The numbers begin with the digit 1, B. The numbers do not begin with the digit 1. Solution for A. We want to build the 4 digits number that begins with number 1. So, we take number 1 and put in front. For the second digit, we have 3 numbers left to choose from and there is no restriction. For the third digit, we have 2 numbers left to choose from and there is also no restriction. Finally, for the last digit, we have only one choice of number. So, the number of permutation that we get is 1 times 3 times 2 times 1 is equal to 6. Solution for B. We have to build the 4 digits number that do not begin with 1. We cannot use number 1 for the first digit. We can only choose number 2, 3 or 4. That means we only have 3 choices of numbers for the first digit. We already used one number for the first digit. There are 3 numbers left to choose from, and there is no restriction in choosing them. So, we have 3 choices of numbers for the second digit. There are 2 choices of number left for the third digit because we have used 2 numbers for the first and second digits. And there is no restriction in choosing the numbers. Finally, for the fourth digit, we only have one choice because there is only one number left. So the permutation that we get is 3 times 3 times 2 times 1 is equal to 18. Example 22. 4 sisters and 2 brothers are arranged in different ways in a straight line for several photographs to be taken. How many different arrangements are possible if A. There are no restrictions, B. The 2 brothers must be separated. Solution for A, where we have 6 people, we want to arrange all and there are no restrictions on how to arrange them. So we have 6p6 equal to 6 factorial and equal to 720. For solution B, we want to find the permutation when the 2 brothers are separated is equal to the permutation when there is no restriction minus the permutation when the 2 brothers are together. The permutation with no restriction is the answer from A, which is 720. For the permutation of the 2 brothers together, we need to arrange the 2 brothers first and we get 2p2 or 2 factorial. Next, we take the 2 brothers as one unit and arrange them along with the 4 remaining sisters. So we get 5p5 or 5 factorial. So the answer is 480 arrangements. Example 23. There are 10 students, out of whom 6 are females. How many possible arrangements are there if A. They are arranged in a row, B. Males always sit on one side and female on the other? Solution for A. We have 10 students and we want to arrange all of them without restriction. So we have 10p10 equal to 10 factorial and equal to 3,628,800. Solution for B. We have 6 female and 4 male students and we want to arrange all of them with the restriction gender is to be arranged side by side. To arrange the male students, we have 4p4 and is equal to 4 factorial. Next, we arrange the female students. The permutation is 6p6 and is equal to 6 factorial. Lastly, we arrange the gender. It's either we arrange the male first, then we arrange the female, or the other way around. We will get 2p2. N is equal to 2 factorial. So the final answer is 4 factorial times 6 factorials times 2 factorials equal to 34,560. Example 24a. In how many ways can 4 girls and 5 boys sit in a row if the boys and girls must sit alternate to each other? Solution for 24a. We have 5 boys and 4 girls. We want to arrange all of them. And the restriction is the gender has to be alternate. First, we arrange the boys in a row. And we leave a blank space in between them. By arranging the boys, we get 5p5 equal to 5 factorial. Next, we arrange the 4 girls in between the boys. By arranging the girls, we get 4p4 equal to 4 factorial. So the final answer will be 5 factorial times 4 factorial equals to 2880. Example 24b. Arrange 6 boys and 3 girls in a straight line so that the girls are separated. In how many ways can this be done? Solution for example 24b. We have 6 boys and 3 girls and we want to arrange all of them. The restriction is the girls must be separated. Consider this arrangement. Let the 6 p's represent the 6 boys. To arrange the boys, we have 6p6 equal to 6 factorial. The cross represent the spaces for the girls. We have 7 spaces, but we need only 3. So, to arrange the girls, we have 7p3. Our final answer is 6 factorial times 7p3 equals to 151,200. Example 25. 4-digit numbers are to be formed from the digits 0, 1, 2, 3, 4, 5, and 6 without repetition. How many numbers can be formed if each number A is less than 5,000? B begins with the digit 4 or 6. C is in between 2,000 and 6,000. D is an odd number. Solution for A. We have to build the 4 digits number that is less than 5,000 and we cannot repeat the numbers given. For the first digit, we cannot choose 0, 5 or 6. So we have 4 choices of numbers for the first digit. For the second digit, there is no restriction in choosing the numbers. Because one number is already used in the first digit, so the number of choices for the second digit is 6. For the third digit, again there is no restriction in choosing the numbers. Because two numbers have been used in the first and second digit, so the number of choices for the third digit is 5. Lastly, for the fourth digit, there is also no restriction in choosing the numbers. Because we have already used 3 numbers, so we are left with 4 choices left. The permutation that we get is 4 times 6 times 5 times 4 equals to 480. Solution for B. We have to make a 4 digits number that begins with the digit 4 or 6, and we cannot repeat any of the given numbers. The first digit must be either number 4 or 6. So for the first digit, we have 2 choices. Because there is no restriction in choosing any number for the second digit, and because one number has been used for the first digit, so there are 6 numbers available to choose from. There is also no restriction in choosing any number for the third digit. 2 numbers has been used for the first and second digit, so we are left with 5 choices of number. For the fourth digit, there is also no restriction in choosing any numbers. We have used 3 numbers for the first, second, and third digits, so we are left with 4 choices of number left. The permutation that we will get is 2 times 6 times 5 times 4 equals to 240. Solution for C. We have to build the 4 digits number that is in between 2000 and 6000, and we cannot repeat the numbers given. There are 4 choices of number for the first digit. They are 2, 3, 4, or 5. After one number has been used for the first digit, there are 6 numbers left. Because there is no restriction in choosing the number for the second digit, so we have 6 choices. 2 numbers have been used for the first and second digit, so we have 5 numbers left. Because there is no restriction for the third digit, so we have 5 choices. Lastly, there is also no restriction for the fourth digit. 3 numbers have been used. We still have 4 numbers left. So for the fourth digit, we have 4 choices of numbers. So our permutation is 4 times 6 times 5 times 4 is equal to 480. Finally, solution for D. We have to build a 4-digit number, which is an odd number, and we cannot repeat the numbers given. In this case, we want to build an odd number. Firstly, we have to consider the last digit. It has to be an odd number. We have 3 choices of odd number, that is 1, 3, and 5. Next, we consider the first digit. The first digit cannot be 0, and one number has been used for the last digit. So, for the first digit, we only have 5 choices of number left. 2 numbers have been used for the first and last digit. There are 5 numbers left. So, the second digit have 5 numbers to choose from. 3 numbers have been used. There are 4 numbers left. So, the third digit have 4 numbers to choose from. The number of permutation that we get is 5 times 5 times 4 times 3 equals to 300. Example 26. Three married couples have bought 6 seats in the same row for a concert. In how many different ways can they be seated if A. With no restrictions, B. If each couple is to sit together, C. If all the men sit together to the right of all the women? Solution for A. We have 3 husbands and 3 wives. We want to arrange all of them with no restriction. We have to arrange 6 people together, so the permutation is 6p6 equal to 6 factorial equal to 722. Solution for B. We want to arrange the 3 husbands and wives, and the restriction is each couple has to sit together. In this case, first we have to arrange the husband and wife for each couple separately. We get 2 factorial for the first couple, the next 2 factorial is for the second couple, and the last 2 factorial is for the third couple. By arranging the husband and wife for each couple separately, we get 8 arrangements. Next, we arrange between couples. We have 3 couples, so the permutation is 3 factorial equal to 6. So we will get 8 times 6 is equal to 48 arrangements. Solution for C. We want to arrange all the husbands and wives so that the husband is on the left hand side and the wife is on the right hand side. First step is to arrange the husband. There are 3 husbands, so the permutation is 3 factorial equal to 6. Next, we arrange the wives. There are 3 wives, so the permutation is 3 factorial equal to 6. The permutation that we will get is 6 times 6 equal to 36. That is all for today. Thank you for watching the video. Please don't forget to do the exercises on this slide. Bye.